All right, so this is that second video for those section 4 notes, chapter 7 of chemistry. And we're going to start with this tetraethyl lead example here. So this 60 that it gives you is actually just useless information. So you got to learn to ignore some things, because if you added the 38.43, the 17.83, and the 3.74, you'd get 60. And yeah, you could do percents, you could do a lot of different things with this, but I just don't really need this, right? Because I already have gram values. I don't need percents to do this. 38.43 grams of lead is a certain number of moles. Now lead's pretty big, it's like 207.2 grams per mole. If I divide that, I get some weird answer, some non-whole number, not nice looking answer. But then I do my carbon, 17 point, oh, that 17 looked a little weird. Let me try that again. 17.83 grams divided by the 12.01. Again, I should probably label some things in here so I know which one's which. But that one's going to give me 1.485 moles. And then I'll do the hydrogen, so 3.74 grams divided by 1.01, and I get 3.703. All right, so now I divide by the smallest. None of them are similar to each other, but that 0.1855 is the smallest. So there's one lead. But I divide everything by 0.1855, and this is going to be really, really close to 8. Divide this one over here, and that's actually going to be really, really close to a 20. Doesn't really matter how big the number is, you'll get it figured out as you go. But this tetraethyl lead is Pb, there's 8 carbons, and then there's 20 hydrogens, right? Now, tetraethyl to me would make me think about organic, and I would kind of rewrite this slightly, because tetra means 4. So if I pulled 4 out of there, right, 8 divided by 4 is 2, 20 divided by 4 is 5. There's 4 ethyls. C2H5 is actually an abbreviation for an ethyl group that's branched off of this lead atom. So if you were in an organic class, you would know this is a real thing, or it could be a real thing. Otherwise, the next few problems are slightly different, right? These are when I already had that work done. I know what the empirical formula is. So I could have done a previous problem and found out that it was this NH2 as my empirical formula. But then I need to know, okay, what if that's not the real formula? What if that's just a reduced form of my real formula? So this is where I'm going to add up the pieces, which 2.02 for 2 hydrogens and a 14.01 for the nitrogen. And I'm going to get this 16.03. This is an empirical mass, right? The formula mass over here is 32.06. If those things don't match, then I'm supposed to divide by the smallest, and that's going to give me a whole number. In this case, it's a 2. And that's how I unreduce my formula. So this is my empirical formula, but if I put a 2 outside of parentheses there, that 2 would multiply inside, those leaches multiply, and you get this dinitrogen tetrahydride, right? So that would be an appropriate answer for this one. Next one, similar. This is my empirical formula, 12.01 plus 1.01. That's going to give me 13.02. That's not the same as the 78.11. But when I divide those two things, I get a whole number 6. And that's how I know that instead of just a CH, this is actually going to be a C6H6. That's my real answer. So then the last example just combines the two concepts together. Right? The first thing I need to do is take my mass of my hydrogen and turn it into moles. And I'll get some weird answer, 4356. And then I'll do the same thing with oxygen. I got 6.92 divided by 16. And I'll get 0.4325. And then I'll notice that, hey, those are kind of similar numbers. When I divide this, it is going to be close enough to a 1 that I can just assume both of these are 1s. But that just gives me an empirical formula. That tells me I have 1 hydrogen for every oxygen, right? But that's not my real formula. I find out my real formula by thinking, okay, if that was my empirical formula, I'd have 1.01 plus 16. That'd be 17.01. That's my empirical mass. If I take 34 and divide it by 17, pretty sure that would give me a 2. So that means that this isn't just a hydrogen and an oxygen. It's 2 hydrogens and 2 oxygens. So this is hydrogen peroxide that we know of. So it's just combining both types of problems together. Get your empirical formula first. Remember this work here, dividing by your mass and then doing a mole ratio. That's how you get an empirical formula. That was just the H and the O together, one of each. But then I have to switch gears, come up with an empirical mass, divide my formula mass by my empirical mass, and then that ratio can take me to a new answer. That hydrogen peroxide, 2 of each, is what I want to end up with. All right, so that should be good enough.